Hello everyone. Today I feature a new song called 10,000 Hours. Here I don't want to dig the real meaning of this song. I just want to say you may know that there is a 10,000 hour rule, or saying that 10,000 hours of deliberate practice are needed to become world class in any field. Okay, although this theory has been challenged by many psychologists, but it's always right that you need to spend a lot of time to become a master in a field. Like Stephen Curry's three-pointer, Kobe Bryant's integrated skills for basketball, and Shaquille O'Neal's weight. Right? One of our instructors of mechanics and materials said that he just passed this course in college. Then when he became an engineer, he found that the knowledge is not enough for him to do good designs. We started to review the theories and do a lot of practices. And finally, he became a master of mechanics and materials, and he came back to academia to teach this course. Okay. I know that now you may not have enough time, 10,000 hours, to become master of mechanics and materials, but you do need to spend more time to get a satisfactory points in exams. Right. Speaking exams, our fourth exam will come in 1 week, and the final exam will be in 2 weeks. Okay, so I just want to say our fourth exam will not be too hard, because you may have realized that some of the contents in part 4 of this course is not that difficult, okay, especially the pressure vessel. Very straightforward. If you understand what the problem is talking about, you can solve it very easily. And the Mohr circle may be a little tricky, but if you spend like 10 hours, 20 hours, you'll become kind of master in those simple problems. Okay, so someone's are asking me the possibilities to pass this course, because they had concerns of their low scores in their first 3 exams. I would like to say, if you wanted to spend more time, everything is possible. It's still possible. In an email I sent a couple of weeks ago, I shared a final grade simulator. Well, you can use it. Okay, fully use that simulator. It's an Excel form. Is fully use it. Type in your grades in the first 3 exams, and estimate the homework grades, in-class assessment, as well as the bonus grades that you may get, based on your own performance. Okay, then you can do a rough estimation of what kind of grades you will get eventually. Okay, if you have concerns, please let me know. Send me an email. I will try my best to reply you as soon as possible. Okay, so today we will just talk about combined loading. That is the last chapter of this course. So our objective today will be simply analyze the stresses in a structural member induced by combined loading. We introduced basic theories before regarding combined loading in earlier chapter, but today we'll just give a general theories, general methods to solve stresses caused by combined loadings. Oh, that will be our chapter 10, combined loading. We will have several examples today, so I will leave a couple of more examples to next Tuesday. Okay, let's give more details on that class, so that you can be better prepared for the exam number 4. Let's start from a simple example. Okay, so here is a hook. Okay, this hook is used to lift a force of 1.2 kilonewton to determine the maximum tensile and compressive stresses at section AA. Okay, the section AA is just somewhere here. Okay, and the cross section is a circular and has a diameter of 35 millimeter. Okay. So just you're requested to determine the effective tensile and compressive stresses at the section. This hook looks like a simple structure since you have only one P applied on it, but it's not that simple. Okay, since if you're analyzing this cross section, this P will have an arm to the centroid, to the local centroid of this cross section. Okay, this is the cross section will be a circle, the local centroid will be in the center, right? So from the location of the P to the center, you will have an arm A. Okay, so this P will make a bending moment to that cross section. Okay, so here will be, you will have a combined loading composed of F as well as M. Okay, you need to consider both of them and calculate the stresses on this section. Okay, so to summarize this, we'll have several steps. The first step, move the force to the centroid of the section, and then calculate the axial force and calculate the moment, and then just determine the maximum tensile or compressive loadings, stresses, okay, due to the combined effect, the coupling effect of these two forces. Okay, so this is a basic example, a simple example to show you what do we mean. What do we mean? What are we talking about? What is combined loading? Okay, so you can see that generally we can solve combined loading, can solve stresses caused by by combined loading in several steps. So in the first step, you always need to move to find out all forces, all external forces, and move them to the centroid of the cut section. Okay, if you have an external bending moment, you just move this moment directly to there. So this will not induce any more extra moment. Right? If you have force parallel to this axis, to the axis of the cross section, then you will have a extra bending moment. Well, that is M equals F times A. Well, here is the example. Well, here is the example. If you have F there, and if you are calculating the stresses on the cross section as shown here, so you need to move this F. This is parallel to the axis, right? Just move this F to here. So it's a P equals F. But since you have an arm A, so this will generate a extra bending moment M equals Fa. Right? So if you have a force perpendicular to its axis, this will generate a kind of shear force as well as the bending moment. Right? I believe you all know how to calculate this kind of bending moment. It's just in cantilever or simply supported beams, how to calculate the value of bending moment based on vertical loadings. Right? So it's the AY, BY, CY, etc. Right? So that is a basic thing. Then in step 2, you will need to determine the section properties. So normally this will include the area, the moment of inertia, the moment of area, and you need to consider perpendicular axis, 2 perpendicular axes in some cases. Assume that if you have a cross section as shown here, and you have bending moment with respect to X and Y. Okay, so you need to calculate 2 moment of inertia, right? So that you can calculate 2 effects, 2 stresses, and then combine them to get the overall stress. So then later you can determine the stresses caused by each force at the point of inertia. Okay, generally if you have an axial force, you will get a normal stress using this equation. A sigma equals F over A. If you have a shear force, you can get a shear stress using tau equals VQ over IT. If you have a bending moment, you can get a normal stress, that is sigma equals MC over I, or My over I, but at a specific point, not on the edge. Then if you have a torsion, you can get a shear stress tau equals Tc over J. Okay, so these are just the possibilities. If you are requested to calculate the normal stress at the point, you just need to calculate sigma 1 and sigma 2 induced by axial force and bending moment respectively, then combine them together. Right? The overall sigma will be sigma 1 plus sigma 2. Okay, if you are requested to calculate the shear force, the shear stress, so you may have two possibilities. Right, just combine them together. But normally, in a beam, we do not consider torque. Okay, so this is just the possibilities. If you have two possibilities, just combine them together. If you have only one due to shear force, it's just one equation. Okay. As I said, sometimes a rectangular cross section may be subjected to two perpendicular bending moment. So you need to be careful in selecting Ix and Iy, the moment of inertia with respect to x and y, those two perpendicular axes. Right? We had a lot of exercises in identifying the correct sizes to calculate the I. Right? In which cases you use bh cube over 12, in which cases you use hb cube over 12. Right? So you should be familiar with those. Okay, in this slide, you can see very similar equations. Okay, both bh cube over 12, but actually we said in the first case, b is here, and the second here, the b is here, because when respect to axis y, this is the bottom and this is the height. Right? With respect to axis, here is the bottom and here is the height. Okay, and you can see these equations, how to calculate I, how to calculate Q, Q equals AD. Right? So in this example, if you are requested to calculate the stress at the point H, well, you can see that in the first, when it's subjected to mx, just with respect to x-axis, then you cut it from here, you get an area, then the local centroid, so that you get a D, and you get a D, so that you can calculate Ix and the Qx. Then you calculate the normal force, then the bending, the normal stress, the bending stress, and the shear force induced shear stress. Okay, then just combine these two, you will get normal stress. Combine these two, you get another normal stress, then add them together. This will be the overall normal stress at point H. Okay. Then we will give several examples regarding combined loading induced stresses. We will start from a simple one, then give harder and harder examples.